Good evening, everyone. This is Team Cosmos in the Vertical Integrated Project 2. These are the team members and the team leader of this group. Okay. First of all, the status of the project and what are the goals of this project in this semester. This is the second semester that we are taking this course. In the last semester, we had worked on the project. But in the previous semester, we had only tested the car, the assembling of processes and testing the sensors. But in this semester, our goal was to use AI and machine learning methods in order to make our partially autonomous RC car. So first of all, we had problems with the main board, so we changed it to a new RC car and then tested all the sensors. They were working properly. After that, we used different open source websites like Kaggle in order to download different datasets for object detection and parking and line detection and crosswalk detection. So this is the RC car based on Raspberry Pi. This is the main thing that we are working on. The RC car and all the assembly parts, sensors were provided by our university. This is how it works. The remote PC will be the starting part of the process. After we wrote the source code and then we start the process, it will go to the RC car and RC car will start running. And then if it detects the stop sign or parking sign, it will move according to the detection. We will show you in the videos. And then this is the camera holder using Fusion 360. Why we needed to print our camera holder? Because the original camera holder was not fixed for the better view. So we needed to print this camera holder in order to get the better view for the camera angle. This is how it looks after rendering. There are some small curves, like sphere-shaped curves in the bottom of the head part. It will be fixed in between these arms so that it can be rotated in about 100 degrees. This is how it looks after 3D printing. This is how the stop sign detection works. The RC car will run until it sees the stop sign. So we used Cascade Trainer GUI trainer using Viola Jones algorithm in order to create our cascade.xml file that is used for stop sign detection and parking sign detection, and as well as the crosswalk detection. As you can see, it can detect the stop signs. We can see it using the video. It stops for a while if it detects the stop sign and then continues on its way. This is parking sign detection. Of course, we had lack of sensors for the RC car in order to create fully autonomous parking, but this is partially. When it detects the parking sign and there is a parking slot next to the parking sign, it will use the sequence of movements to park itself to the parking slot. This is line detection. We are using tracers, like line tracers, in order to trace the line and move the car along the line. And of course, we tested the stop sign detection again. It stops for a while and then continues on the way. So what are the challenges we had? Like I talked about the main board, we needed to improve the accuracy and precision of the trained models, because when the trained model saw the stop sign or parking sign, it was like sometimes giving error. It couldn't detect properly, and we had to use different datasets from the websites, like bigger datasets for the better accuracy and precision. So the next challenge was with 3D printing. After 3D printing, the camera couldn't fit in the inside of the 3D printed model, so we needed to 3D print it again. So the last challenge is lack of sensors for self-parking processors. If we have, for example, many cameras or many IR sensors on every side of the car, we can detect for example, objects around the car so that it cannot crash those objects. Future plans, so maybe in the next semester we can improve the quality of our project. We can implement traffic light recognition. For example, if it's red, the car will stop until it waits until it turns green. For example, we can implement object recognition, like the car can detect humans, cars, bicycles around it, and we can also implement other road sign recognitions, and behave the car according to the road sign rules. For example, if it's the maximum speed limit is 50, the car will go like in the 50 speed limit. Okay, this is it for our presentation. Thank you everyone for listening.
Okay, I have a question. When you park, you should drive backward, right?
Yes.
So, in that case, how do you recognize the parking lot? You have to recognize the sign and the lines of the parking lot.
On this one, actually, it reflects parking sign. Then after that, it's like for design for special position. Only this position. It only like when it sees the parking sign, it's designed for parking on the left side. On the right side.
Okay.
It doesn't affect the parking sign.
So it's kind of fixed.
Yes.
Yeah.
Yeah.
Thank you.
Okay, thank you.